Hi students, this is the outline of a partial differential equation. So first session we are going to see the elimination of arbitrary constant. Next second session we are going to see the elimination of arbitrary function. Third session we are going to see the standard type of partial differential equation. So in that we are going to see the type 1 and type 2. Next session 4 we are going to see the type 3 and type 4. In a session 5 type 5 and type 6. In a session 6 homogeneous and non-homogeneous partial differential equation. In the session 7 we are going to see the Lagrange's method. Today's session, first session, we are going to see the elimination of arbitrary constant. So consider an equation f of x comma y comma z comma a comma b equal to 0. So here a and b denote the arbitrary constant. A partial differential equation is formed by eliminating this arbitrary constant that occur in the functional relation between the variables. So in this unit we are going to use the following notations. Dou z by dou x equal to p, dou z by dou y is equal to q, dou square z by dou x square equal to r, dou square z by dou x dou y equal to s, and dou square z by dou y square is equal to t. So now we are going to see the problem. First one, form a partial differential equation by eliminating the arbitrary constant from z is equal to ax plus by. So given partial differential equation is z is equal to ax plus by. So from this given equation, we have to eliminate the arbitrary constant a and b. Then we have to form the partial differential equation. Now we consider the equation this as given equation as 1. Differentiating this equation 1 partially with respect to x. So if you differentiating this z, I already explained that this z is a dependent variable. So therefore this z can be differentiated with respect to x as well as with respect to y. So now we are going to differentiate with respect to x. Dou z by dou x equal to, so here multiple of x is having a. So differentiation of x is 1. So here no x variable is having, therefore this second term become a 0. So dou z by dou x equal to a. So we know the notation for dou z by dou x equal to p. So from this we can write p is equal to a. Next, differentiating 1 partially with respect to y. So this side, left side can be written as dou z by dou y is equal to, so here no y term is having, therefore this first term become a 0. Then the second term with respect to y, if we differentiate, the differentiation of y is 1. So only we will get the b. So we know the notation dou z by dou y is equal to q. So from this we can written as q is equal to b. So we find out that a is equal to p, b is equal to q. Substitute this a and b value in given equation. Therefore, we get z is equal to px plus qy. So this is a required partial differential equation. Next, we go to the second problem. Obtain partial differential equation by eliminating arbitrary constant a and b from x minus a the whole square plus y minus b the whole square plus z square equal to 1. Now, this is a solution. Given, we have to take given equation as x minus a the whole square plus y minus b the whole square plus z square equal to 1. Now, we are going to differentiate this equation partially with respect to x. So, partially with respect to x, this x and y are, I already explained, this x and y are independent variable. This z is a dependent variable. Wherever z is having, we can put dou z by dou x, then dou z by dou y. So now differentiate this equation with respect to x. So first point, differentiate the power. So 2 times of x minus a into differentiation of x is 1. Next, second term no x variable is having. So therefore second term become a 0. Then the last term, this z is a dependent variable. So therefore we can differentiate with respect to x. So differentiation of z square is 2z into dou z by dou x equal to 0. Next, we are going to differentiate. From this, we can write as 2z into dou z by dou x equal to. So, bring this 2 into x minus a to the right hand side. So, we can write minus 2 into x minus a. From the both the sides, we have a 2 is common. So, we can cancel the 2. And we know the notation dou z by dou x equal to p. So, zp is equal to minus of x minus a. So, from this, we can write x minus a is equal to minus zp. Take this as equation number 2. Next, differentiate the given equation partially with respect to y. So, first term you have only x is having. So while differentiating with respect to y, first term become a 0. Then the second term twice y minus b into differentiation of y is 1. Then this one I already explained. This z is a dependent variable. So therefore we can differentiate with respect to y also. So 2z into dou z by dou y equal to 0. So from this we can keep this side, we can keep this term as a left hand side, then bring this term to the right hand side. So from the both the term we can cancel the 2's common cancel. Then from this we can write dou z by dou y is equal to q. So zq is equal to minus of y minus b. So y minus b is equal to minus q. So take this as equation number 3. So after finding the x minus a and y minus b, so here we can't directly, previous problem we directly find the a value, b value, then substitute in the given equation, we eliminate the a and b. So from this problem we cannot find the a value, b value directly. So from this we can we can substitute this equation 2 and 3 in the given equation. So what is the given equation? X minus a the whole square. Instead of x minus a, we can substitute as minus zp. So minus zp the whole square plus minus zq the whole square plus z square equal to 1. So here all the term have a z square is common. So take out the z square common. So z square into p square plus q square plus 1 equal to 1. This is a formation of partial differential equation. So next we are going to the problem number 3. Form a partial differential equation by eliminating the arbitrary constant a and b from the equation x minus a the whole square plus y minus b the whole square equal to z square cot square alpha. So consider the given equation as 1. Now we are going to differentiate this equation partially with respect to x. So previously explained, no? So here previous problem here plus z square is having, here we have right hand side z square having. So 2z into dou z by dou x into this cot square alpha as a constant term. So this one write as it is. Then x minus a is equal to zp cot square alpha. Then again differentiating partial with respect to y, we get y minus b is equal to zq cot square alpha. So fine, after differentiating, substitute the value x minus a and y minus b in the given equation. So can be written as zp cot square alpha the whole square plus zq cot square alpha the whole square equal to z square cot square alpha. So if you square this term, you get the z square p square cot power 4 alpha plus z square q square cot power 4 alpha equal to z square cot square alpha. So all the term z square is common. So we can cancel all the z square. Then also you can cancel the cot square alpha also. So remaining we get p square cot square alpha plus q square cot square alpha equal to 1. So from these two terms we can take out the cot square alpha outside. So p square plus q square equal to 1 minus cot square alpha. So we know that 1 by cot square alpha is equal to tan square alpha. So this is a required partial differential equation. Next problem number 4. We are going to see the find the partial differential equation of the family of spheres having their centers on the line x equal to y is equal to z. So here there is a equation of the sphere you have to write. So for that sphere, the center is given as all the axes are equal. If we consider A is a center for x axis, then A is a center for axis y. Then A is a center for the axis z. And also know the radius is r. So how to write the equation of the sphere? X minus a the whole square plus y minus a the whole square plus z minus a the whole square equal to r square. So now differentiate this equation with respect to x. So previous problem and all, they gave the equation. So in this problem, we are going to frame the equation first. Then afterwards, we have to differentiate partial with respect to x. First term, it becomes a 2 into x minus a plus second term, no x variable having, therefore 0. Then this term, that is z is a dependent variable. So twice into 2z minus a into dou z by dou x equal to 0. So here this r square is a constant. Therefore, right hand side equal to 0. So here write 2 into x minus a. Bring the term to the right hand side, can be written as minus 2 into z minus a. We know the notation for dou z by dou x equal to p. So from this x minus a, bring the p to the side. X minus a by p is equal to minus of z minus a. Next we are going to differentiate one partially with respect to y. So twice y minus a plus twice z minus a into dou z by dou y equal to 0. We know the notation for dou z by dou y is equal to q. So bring the term to the right hand side. So we can cancel the 2 common. Then we can written as y minus a by q is equal to minus of z minus a. So from equation 2, we can written as x minus a is equal to multiply the p inside minus pz plus ap. So bring the pz to the side. X plus pz is equal to a plus ap. So from this term, take out the a outside, can be written as 1 plus p. So from this, a is equal to x plus pz by 1 plus p. So similarly, from the third equation, a is equal to y plus qz by 1 plus q. So substituting this 4 and 5 in the, here the 4 and 5, both the left hand side are equal. So therefore, we can equate directly the right hand side. So therefore, x plus pz by 1 plus p is equal to y plus qz by 1 plus q. So this is then cross multiplying. Then we have to equate. Then we'll get the partial differential equation. Over.